Welcome to Module 4 on compound inequalities. Right now, pause the video, make sure you've got your writing utensil and your notebook for taking notes. If you don't have one, you need to get with your teacher right now and make sure that we have a way to get you one. Note taking is important because that way you'll have access to what you're learning without having to rewatch all the videos. Plus, don't forget you can use your notes on the quizzes and the assessments, so that's some incentive for you to take good notes. You might want to start a new notebook page. This is Module 4 on compound inequalities. And today we're going to be talking about translating sentences into compound inequalities, graphing compound inequalities on the number line, writing a compound inequality yourself given the graph, and solving a compound inequality. We need compound inequalities when we want a set of numbers that fall in between two numbers, or you might hear me say out between two numbers, which essentially means the outsides, not in between. This is going to be useful when we're finding domain and range of a function in the next lesson. So a compound inequality is essentially just two inequalities put together. So I want you to make a new topic, graphing a compound inequality on the number line. So see how this word says and? That's telling you that this needs to be in between two numbers. What we've got are some numbers that are greater and less than or equal to 7. So remember we learned last time that we need shaded in circles when we have less than or equal to's and greater than or equal to's. And because this says and, I want the stuff that's greater than 0 and less than 7. The only place that that's true is here. If I try to shade it out here, that's incorrect. For example, like -2 would be less than or equal to 7, but -2 would not be greater than or equal to 0. If I try to shade out here, that's also correct. 8 would be greater than or equal to, but it would not 0, but not less than or equal to 7. Let's try this one together. I see the word or this time. What this means is it could either be one or the other. This is what I call out between instead of in between. We're talking about 3 and 6. There's lines underneath, less than or equal to, greater than or equal to, tells me to shade in these circles. What we're talking about numbers that could either be less than or equal to 3 or less than or equal to 6. We cannot use and for this one because there are no numbers that are both less than or equal to 3 and at the same time greater than or equal to 6. You pause the video and try these two on your own. You should have noticed that this one said and, which is telling you that it's an in-between. So the numbers are -2 and 0. We need shaded in circles for both because they both have equal to signs. And we want the stuff that's greater than or equal to 2 and at the same time less than or equal to 0. That is in between those two numbers. This was an or problem. The two numbers were -7 and -1. The -7 needs a shaded in circle. The -1 needs an open circle because it's greater than. This time it's an or, that's telling you it's an out between problem. These numbers could either be less than -7 or greater than -1. We don't say and because that's not possible at the same time. So essentially, for a compound inequality, we're just putting two inequalities on the number line. It's either in between or out between. Let's talk about how we can recognize a compound inequality when we're translating. So let's start a new topic. Please write translating a sentence into a compound inequality on your paper. And I see some word problems, so you should probably make a new list of code words for this and be ready to write those down. I see 5 is less than or equal to x, and x is less than or equal to 9. And it says use x only once in your inequality. So let's start by graphing it. Let's see if we can figure out what that should look like. 5 is less than or equal to x, looks like this. Well, that looks kind of odd to me. I'm going to flip this around so that the variable's on the left. So that's the same thing as x is greater than or equal to 5. For this one, x is less than or equal to 9. So what we've got is 5 and 9. We've got a shaded in circle here and a shaded in circle here. And we want to show that it's and, so it's in between. I see the word and, so it's in between. What they want is for us to write this using a compound inequality. We put x in the middle. We put the number on the left. We put the number on the right. And then I'll tell you a secret. In between is always less than or equal to, less than or equal to. 5 is less than or equal to everything else. Everything else is less than or equal to 9. So it's like a progression. 5 is less than or equal to x. X is less than or equal to 9. You pause the video and try this one on your own. So you should have gotten -3 is less than W, and then I don't need an equal sign there because it's just less than. I don't like that. I'm going to flip it around so that I can see that W is greater than -3. That makes it easier for me to graph. And at the same time, W is less than 6. So my two numbers are -3 and 6. I need open circles. I want the stuff that's greater than -3 and at the same time less than 6, so that's in the middle. If you don't need to do the graph to skip to the next step, that's fine. You don't have to, but we need W in between -3 and 6. These were open circles, so we use less thans. Nice job. It says write a compound inequality for the graph shown below. So this is exactly what we were just doing, except now we don't need to write our own. We don't need to write our own graph where they're giving us the graph. So this looks like an in-between problem. So I know this is going to be an and. I want 1 in the middle, or excuse me, I want 1 on the left and 3 on the right-hand side. The x's are shaded in the middle. And remember, it's always the same way. It's always less thans. The 1 should have a line underneath, the 3 should not because it's an open circle. You can kind of envision this as the shading. What we've got is this, and everything else in the middle with the shading in the middle. If it's an OR problem, this is telling me it's an OR because it's out between. I can't write this as one inequality. It just stays separate with an OR in the middle. So it's x is less than or equal to -2 because it's a shaded in circle, or x. You pause the video and try these two on your own now. You should have recognized that the shading is in the middle and you're in between -2 and 7. In between is always shown using less thans because -2 is the smallest, it's less than everything else. X is in between -2 and 7, and everything is less than 7. And then I need lines to show that those were shaded in circles. For this one, it should have been an OR problem. You need two separate ones. On the left, you want the stuff that's less than -3. I don't need a line because it's an open circle. On the right, I want the stuff that's greater than 6. I don't need a line because it's an open circle. Now let's talk about solving these. I want you to make a new topic, solving a compound inequality. This type with the OR, you already know how to do. All we're doing is solving two inequalities separately, separated by the word OR. So for this one, we just solve like normal, subtract 2 from each side, so 4x is less than -20. Divide both sides by 4, so x is less than -5. For this one, we add 6 to each side, so 3x is greater than -6. Divide both sides by 3, so x is greater than -2. Graph, we just graph the separate ones. -5 on the left, -2 on the right, open circle on the -5, shade to the left, open circle on the -2, shade to the right. This is an out-between problem, not an in-between problem, because it says an OR. This one is going to look very different. We are typically used to solving an equation like 3x minus 6 equals -15 with a line down from the equal sign and recognizing that there's two sides. Now, we want to envision this as if there's 3 sections. So we would solve this by adding 6 to each side. But now there's 3 sections, so I would need to add 6 everywhere. This would become -18, the -6 and the +6 cancel. -15 plus 6 would be -9. We would divide everything by 3, and we would finish from there. Our goal would be, just like always, to isolate the x in the middle. So this would become -6 is equal to x is equal to -3. But that's impossible. The equal signs don't work because we have to have less thans here. So we're going to recreate this whole process. Our goal is to isolate x in the middle. You want to envision this as if there are 3 sections to your inequality, and you're trying to get x alone in the middle. Your first step would be to add 6 to each side. In this case, there are 3 sections. -24 plus 6 is -18. We bring down the less than or equal to, bring down the 3x, the -6 and the +6 cancel. -15 plus 6 is -9. X is not isolated in the middle. We're going to divide everything by 3. So we get -6 is less than or equal to x is less than -3. To graph this, I want to show that it's in between -6 on the left, -3 on the right. Because of the line underneath with the -6, we shade in that circle. There's no line here, so that's an open circle, not shaded in, and we shade it in the middle to show that we're talking about the numbers in between -6 and -3. You pause the video and try these problems on your own. All right, you should have just treated these as two separate inequalities. It's an OR, which means I'm going to end up putting them on the same graph. Thing is exactly the same. We add 3 to each side, so 3x is greater than or equal to 18. Divide both sides by 3, so x is greater than or equal to 6. Bring down the OR. Add 6 to each side for this one, so 3x is less than -6. Divide both sides by 3, so x is less than -2. The only thing I thought was tricky about this one is that you need your small number on the left and your big number on the right because this is a number line. We want the stuff that's less than -2 or greater than or equal to -6. You should have shaded in that circle because there's a line underneath. You should have not shaded in that circle because there's no line underneath. For this one, remember the goal is to get the x alone in the middle. If you had 4x plus 2 equals 10, your first step would be to subtract 2 from each side, not do anything with the 10. So in this case, I'm going to subtract 2 from the middle, subtract 2 from the right, and subtract 2 from the left. That leaves me with -12 is less than 4x is less than 8. Now I need to isolate x by dividing everything by 4. So -3 is less than x is less than 2. This one's an in-between, not an out-between. We want to show that the small number is on the left, the big number is on the right. You should have done 2 open circles because there's no equal signs, and we shade in the middle to show that this is in between -3 and 2. And that's it. This video will be available on Haiku if you need to rewatch, and will be available on each skill for Module 4 in ALEKS. You want to make sure you log on and do the Module 4 practice problems in ALEKS. If you have a question about a problem in ALEKS, click on the tab that says Explanation. You'll get an explanation and a solution before you move on to a different problem. And then don't forget that you need to take your assessment. So there is an assessment 4 that goes with Module 4, and that's called Quiz 4. So I tried to make it as easy for the naming as possible. All right, guys, thanks so much.